So thank you. Um, we're talking about front-end development in complex projects. It's also our first talk, like for Roger before. Um, we're excited to be here. First, some sentences about us. I'm Rosemary Wiesire, just Romy. I don't like my name so much. I made gymnasium in psychology and economy, then the SAE here in Zurich for creative media, and then I made a bachelor in computer science in the University of Applied Science in Bern. I'm working as a front-end engineer in Unix since July 2011, and I think working from front-end, so first website was about year 2000 there.
So my name is Thomas Jacke. I actually studied food science, but somehow got on the wrong track. So we both work for Unic, which is one of the leading providers for e-business solutions in Europe. And we are going to talk about some typical issues in the front-end development process and how we tackle them. Now, to get you on the same page, when we talk about complex projects, it's not only about complex code, it's also about the whole process. So you may have a lot of people involved. Some of them may work remote. You have to work together with other companies. Sometimes you work with other teams at the same time. Sometimes it's one after another. Then it's difficult to talk to each other. If you're already on another project, when someone implements your HTML prototype or something, so there you have different problems. Another thing is the uncertainty. So we might not know what the whole page is going to look like when we start with our prototype. That just happened at the current project I'm working on. So the design is delivered from another agency, and they basically hand over page templates every week. So when I started, I had no idea what the whole site was going to look like. I didn't know if the element I saw on the landing page would be used on another page as well. So that's one issue. The other one is the interface with the backend. It might not be specified yet whether something happens server-side or in the browser. So we have to be aware of all those uncertainties. Now, my part will be about writing maintainable and scalable HTML, CSS, while Romy will talk about JavaScript and more complex setup issues. Now I will show you 5 basic issues we had in the last years. So one of them is redundant HTML code. Now you might get something like this. So you already started with your prototype and then something is added. Usually we, like Roger told you, we receive like 20 or 30 templates, Photoshop templates or fireworks or something, which we then might translate one-to-one to HTML files. So if you have to change something, you have to do it in a whole lot of files, which is a pain. Now, you might use find and replace over the whole project, but if the structure is not exactly the same, that might be an issue. And our solution for this problem is the modularization of our HTML, and we use one specific tool for this. So are there any of you who know Middleman or who use Middleman? Okay, nice. It's a static site generator in Ruby, and it's open source, like Clarify. And basically, you can use partials. So you don't have to put your header in every HTML file. You just put it into a partial and use this all over the place. Now, we don't use ERP, like in this example, we use Haml, but the structure is basically the same. Now I will show you how to set up a project in Middleman. That's that. Yeah. The syntax is pretty easy. Let's call it demo. And we can use a template we predefined. Now it's gonna install some default dependencies. You can of course change them if you don't need all of those things. So CoffeeScript, SAS, Compass, whatever. You might not need all of them. And that's what it looks like after setting up. So my template I used already had those partials predefined. For example, one for a footer, one for a header, navigation, sidebar. Then we have one general layout file where those partials are included. And we already have one page which is called index. So to preview this in a browser, we just start the dev server. And that's what it looks like. So let's add another page. Copy this content. And there it is. So you don't have this redundant HTML anymore. You can split up your code, which is a lot easier to maintain. Now, we don't want to hand over a middleman prototype to the backend. So instead, we create a static prototype. And now we have this folder consisting of some assets we defined and static HTML files. So we can still deliver a static prototype like we did before, but we don't have to code with a static prototype. Nope. So, of course, there's a disadvantage. You need this build process. Nobody without middleman installed can work on your prototype. Now on a Mac, that's not a big issue. It's a one-liner to install. On Windows, you might have to install Ruby first, which I was told is not as easy as you might expect. So that's a disadvantage. You need this tool. And when you first look at the code, you might have to search for specific code since it's split up. So might be an issue. However, if you use this tool all developers use it, and you create a template project, everyone starts with the same project structure. Every project you start can have the structure you predefined. So let's say we have this asset folder with CSS and JavaScript. We could add some boilerplate stuff there. We could add JavaScript libraries we want to use all the time. So you have a common boilerplate for every project. And it looks the same when you switch projects, you work on another, it always looks the same. You don't have to get to know another boilerplate all the time. Now the second issue is location-dependent CSS. So you might want to use a specific module at a place you didn't anticipate. So if you write CSS like this, where your teaser element only works in a sidebar, you're screwed. You can't use this teaser, let's say in the main content area. Well, you can, but no styles are applied. And there's an easy solution there too. So you use modularization for your CSS as well. You might have seen it in Roger's demo. They use modules for their specific content areas. So basically you create CSS objects, or like in this famous object-oriented CSS approach, where a CSS object is defined as some HTML, CSS, possibly even JavaScript. And the important thing is you can reuse this element. So it's not tied to a specific location in your layout. It's a teaser, and it doesn't matter where it's used. There are different approaches. So yeah, like the original one by Nicole Sullivan, you might have heard of SMAX and BEM or BM, I don't know. OOCSS is not just an approach, but also a framework with code examples. SMAX is more like an approach to structuring your CSS by the use of namespaces. So you think about what type of element is this? Is it well, does it structure the whole site? Then it might belong to the, he calls it layout category. Or is it a specific element? Or does this selector like describe a state that an element is hidden or visible or something? And well, we see it here. Depending on this category, you have a different namespace. So when looking at code in SMAX, when looking at selectors, you get an idea on what is happening. So this is a state, like this teaser is featured. If you'd write this with the official OOCSS approach, it might look like this, where you have this block with specific components which are common in those blocks, like a body or a title. With this BEM approach, which is actually much more than just an approach to writing CSS, then you might end up with markup like this, where you have a specific modifier. So this BEM stands for block element modifier, where you have a modifier to this teaser block, and you have sub-elements which are prefixed with their parent block. So you might have to choose with your team which approach to use, which one you prefer. I personally like smacks a lot. However, I don't particularly like this thing. We'll see why later on. And I'm also thinking about prefixing my independent modules with something like module or block. So the code you've seen in Roger's presentation, well, you see this is an independent module. You can use it well somewhere else. But if you just have these non-prefixed classes, you don't really know, is this an independent module or is just the title an independent module? So if you prefix your modules as well, it's easier to read. Now the disadvantage, of course, depending on the approach, you get additional markup. We'll talk about selectors later on. Another issue that the CSS assumes too much about the markup. So that's something we often hear when we hand over a prototype to the backend, and it usually looks something like this. So the CMS or whatever system, the shop system or whatever, inserts extra markup. So using CSS, which relies on a specific structure, might be a problem. For example, if the title has to be the immediate child of this teaser block and something else comes in between, this selector doesn't apply anymore. Same is true for sibling selectors, similar ones. So my approach is just to use additional classes, then it's flexible. It doesn't matter if it looks like this. If you remove this specification, it gets easier. So do you or does anyone know how selector matching works in a browser? Okay, so, well, it starts from the right. It's not like we might read CSS, since the browser starts with an element. So let's say he walks the DOM and arrives at this div. Then it's parsing every existing CSS rule and looks at the key element and tries to find out whether this one applies. So for our container, this wouldn't apply. Let's say we are at the title. This applies. Then we go to the immediate parent, check out whether this applies. So this is actually slower than if you just use a class directly. So just matching title is faster than matching this whole selector, since when you match this, you have to go further up the DOM tree to see whether this applies. So if we go back to this approaches, using like those prefixed classes directly is actually faster in terms of selector matching. So we might even get a performance impact, well, a performance improvement if we avoid those kind of selectors. But in practice, that might not be measurable, so just theoretically. Well, if your DOM is pretty big, if you have thousands of nodes, it might be an issue. Then it's, of course, faster without those complicated selectors. So, however, not using them is kind of sad, since they are useful. Most of those new CSS3 selectors are pretty useful, but yeah, they are theoretically slow in some cases. And with an approach with additional classes, you have extra markup. So you have much more code, which is, yeah, not too nice. But anyway, if you gzip your HTML, for example, you might not see a big difference between an approach without extra classes and one with. So in practice, it's generally okay to use this kind of extra markup. Then the next issue is about not separating JavaScript from your markup, or not separating it enough. That usually starts with a conversation like this, and then you find out that the markup was changed. For example, a class was removed, and your JavaScript functionality relied on this class as a hook. So, for example, if you have a carousel or something, and you initiate it on this class, it obviously doesn't work if you change this class. The solution is actually, well, there are several, of course. One of them is using additional namespace classes for your JS hooks. So, for example, with a JS prefix, this class might not be used in the CSS, just as a hook to initialize this carousel. Another approach is using data attributes. That's actually what I like, where you have, for example, a data attribute init, which would then initialize your carousel. You can pass options, of course. You can also use data attributes to mark specific DOM elements you need for this carousel. So otherwise, you just have to assume that all child elements of this unordered list are used in this carousel. If you specifically mark them, you could theoretically exclude some elements from this carousel. So that's a possibility to remove specific markup dependencies from your HTML, from your JS. One problem is data selectors are slow. You have to match every existing element in the DOM and well, assess whether it has this data attribute. Now, with a standard page, that's probably not an issue. But again, if you have a lot of DOM elements, it's slow. And again, extra markup. And the last thing is inconsistent code style. I had to cry when I saw this. So the problem is everyone codes differently. So I like to have like an indentation of 4 spaces with my CSS declarations. Some others have different, well, like different things. That's well on a code level. Then the structure. So where is the CSS for this module located? Another thing, yeah, the one I mentioned here. So refactoring stuff because you don't like the coding style is a bad idea. Now there are different approaches to coding style guides. This is an example from GitHub where you define the details of your code. So how many spaces to use, where to use them, whether you use like different lines for all your properties in the CSS and stuff. This, of course, takes a lot of time to develop since your whole team has to agree on one. Or if you have, well, just the boss deciding, that's another possibility. But it might not be fun, so coding style guide in general is restricting, but I guess it's worth it. Since the code is readable, it always looks the same, no matter who wrote it. So if like a remote developer comes onto this project, it looks the same like the last one. But the time to develop such a coding style guide is usually the problem. So we are, well, we have our day-to-day work. We usually don't have enough time to discuss such things. And then we end up with different coding styles. And sometimes it's a mess. So I really advise you to take this time, discuss which kind of style guide you want to use, and then be strict about it. There are different possibilities. So Chris Coyer recently had a pretty impressive list. Those are just 3 of them. So just as some examples.
So now we have really a well-organized front end, and we as a front-end team can work well together because we all know where our code is. And now I like to more talk about the interface with the backend. So we're developing a standalone prototype. Really, we're working with our own data and not with the real interface from the backend. So we have to mock these data in some way because we don't have the backend. Often the backend does not exist, and this time we're beginning with the front-end prototype. So think about a normal website. Normally you have one little function that loads some data, some JSON or HTML, and that's quite easy to mock because you just create a file in your file system, make a configurable URL, and that's it. That's pretty easy. But now we have really complex web applications, and there we're not just loading some data, but also we're reading and store data and update these data. And for this, we're working with Backbone. I think you already know it after today. And Backbone really creates beautiful REST URLs. But REST URLs to mock, you'll see you will have problems because you don't have a file ending or such a thing, and you would have to create a file for every ID your objects could have. So in your project, this won't work like this. You can't just create a file for every ID you could have in your prototype. So does anyone of you has an idea how we could mock these data away? No? Okay. We had some problems too. Our approach was to override the Backbone sync because the problem was all the Backbone interface. So you see here some really, really simplified code. We just store the original method. If we don't find a mock, we just go like we hadn't any mock. And the cool thing here is we can really handle the ID because then we really don't have to mock every ID, every URL. And such a mock would look like this. So we can define really a base URL for our module, and then we have a function for each CRUD method. So create, read, update, and delete. And the cool thing is we can return some arrays, some empty objects, and we can even have some code in it. And this one is quite a typical use case, because if working with a backend and store some data, mostly the database creates the ID and not you in frontend. The database creates the ID. And if you would just return always the same ID, then you would one time in your backbone collection make create, and then nothing works anymore after twice create. So like this, we can really simulate our front end quite good. So this is quite nice, and it really works. But if I would be at the same point of this specific project some months before, I would not do it like this. Because you should always try to mock as less as possible. So I would prefer to mock the jQuery Ajax, because inside the backbone sync, you're calling the jQuery Ajax. So what happened here is we have mocked away some important functions of the backbone sync. So we got some problems there. So just try to mock away as less as possible. And like I said, working directly with the backend was, for us, it was not possible because the backend was not there. But I'm now quite happy that it was not there, because we never have a dependency. So we don't have to say when the backend is new deployed, if the backend is available, or we can work offline. That's no problem, because when you have really the backend URLs, you have to be online. Perhaps you have to be in VPN, mostly. And the other thing is, if the backend destroys something, and that happens sometimes, and we really have a working front end, and we can say, hey, look, I said you should respond like this, and you don't do this anymore. So we have a working front end that proves how it should be. And that's quite nice, because sometimes it happens that we find some errors. So in the next topic, I like to talk with you about unit tests. Unit tests is such a huge topic, and this really just some little thought why it's so important to have them in a web application. Because in web applications, you are reading and writing data, and and the interface to the backend is well tested in backend. So why not in frontend? So now the questions: who of you already write unit tests for JavaScript? Quite many. Cool. We're doing our first step. So I'm not an expert. We're writing some unit tests. We're now really learning it. And we're beginning with the most important functions and with the interface to the backend. That's really important. That has to be tested. But we do not test just a add clause for some styling so that you don't have to test, or just a call of a plugin if you have some jQuery plugins or something. So, our last topic, the continuous integration. If you're thinking a static standalone prototype, you will say, hey, what is this for? For us, we don't have it since a long time. So perhaps, does anybody already have a CI server for the front end? Okay, more than I thought. It's pretty cool. So I'd like to show why and how it's working for such a complex project, or it could work. Like you have heard from Thomas, we're using some preprocessors like HAML and SAS, and we have to build these files. So our HAML has to be built into HTML. We have some SAS files that have to be merged into one file, because we don't want to have such many well-organized files, but we don't have to deliver them all. And the same thing about JavaScript. Currently, JavaScript we're merging with Sprocket, because that's quite nice in a Ruby environment. And these tasks all can be done by middleman. So, as you have seen from Thomas with middleman build, that's pretty cool, but that's on our machine. So no backend developer can work with these files because they are on my machine. And you should not check it in the SVN just because the backend developer can then take these, because an SVN, it's a source repository or Git or something. And you should not check in generated content. Source repository is for sources. So we have now really well-organized code. We can build it, but no one gets them. That's a little bit sad. So for this case, our IT installed a server, a Ruby server. And that was, at the beginning a little bit, we had nobody with real Ruby know-how. And a little bit you need. But now it's up and running, it's great. So we first check in just the source into the SVN, and then we have the build server that checks for update and sends the source to the Ruby server. And there we are always building two versions. We have a release version. There we do minify the files just for the release. But that's not so good as a developer version. You can't debug in the right way. So we also build a developer version. So now our backend can go to the build server, Jenkins in our case, and can take these files. But can he now work with these files? Are they now really usable for him? No, they aren't. Because you have so much requests, and just double-clicking the index file, that won't work. You have requests and everywhere some configured paths, and it's not really usable. He has the generated sources, but usable it's not. So we added one more step to the workflow. We have an automatic deployment on an Apache web server. And there, really, everybody of the team, no matter if a project leader, a backend developer, or everybody can go to the server. He sees the actual content of the front-end prototype, and he can follow the requests, what's going on, what's sent to the server, what should come back. And that's pretty cool. So that's now here, now they can really work with. So this is about our daily process, but one day we have to release that web application. And in my project, that's pretty often because the customer is really complicated. So we have some files like JS and CSS. They are built and minified and ready to release, no problem. But then we have our HTML and mocks, and they have to be integrated manually in the backend. And so you should not change here anything a day before the release. That's not a good idea because it won't work anything anymore. So that's for us, that was the point we're getting used to. At the beginning, we often had something that on the release day, they just didn't work anymore. But now it's getting better. Because for most front-end developers, such things as we do a branch or merging the things is not so daily. So it uses some time to get used to. And now we're here thinking about having a machine that some HTML changes we can do directly in the backend system. Because creating a ticket for the backend, just please add this class to a specific div, that's not so funny to wait 2 days for a class on a diff. So we try to do this ourselves, but you need a little know-how. Not every front-end developer can work with JSP files or something. So yes, and that's it. Our web application is released, so we're happy. So that was a little insight in our work. We're still doing our steps, so it's not everything finished, and our coding guidelines are also in progress, yes, because of the daily work. I hope somebody of you can take some thoughts about it into your days, and we thank you for your attention, and it would now be the time to discuss.
All right, I have a question about, so you were talking about the mocking,
Yep.
that you mock the backbone.sync or you mock the Ajax calls.
Yep.
Did you consider using local storage instead? And just storing it there instead of mocking out all of the calls?
Currently not, no, but would be a good idea.
All right.
Sure.
Actually, thanks for asking almost my question. I was wondering about the same part. So you told that it's good to mock as little as possible. So you started with a sync, then you went to jQuery.ajax. Why not mocking the models themselves and like checking what's going on if the save gets called, if fetch gets called? Why isn't it good enough?
I just knew Backbone not good enough to think about other approaches. So it's our first project with Backbone, and I think it can be done better.
Maybe I can help then a little bit. Then it's not really a question, then it's a command. So
yeah.
Probably what would help is passing these models explicitly to the places where they're used and really making the dependencies explicit. And as soon as you do this, then you can mock on those things that you depend on, and then you can like not go down to jQuery and just stop on the model level. So that may help.
Okay. Yeah. I will think about it. Thank you.
First, a note. There is since you're using Rails, there is a gem for Rails that generates mock data, and you can have the database, and it basically, for instance, you can tell it this is a first name field, and it just sucks realistic-looking first names and cities and things like that, and builds you a database that looks real, so you can test on that, and it's a very useful thing to have. But then you would have to have the backend running. It's a very handy thing. We use that. Another question: what do you use for unit testing? RSpec or in Rails? And do you use Cucumber?
QUnit.
Do you use Cucumber and RSpec?
What?
On Rails. Cucumber and RSpec.
No.
What do you use there?
QUnit.
Okay.
Any more? So last word. We're also hiring, so yeah. We're searching front-end engineers every time, also designers and interaction designers, so have a look. And if you're, yeah, and also a lot of other. And if not really this is there that you're searching, to try it anyway, because we're just searching good people in a good team. Thank you.